Have you ever noticed that when you're at a beach, and this is a pretty nice one, a picture I found. Let's say you're at a beach and the waves that come into the shore, they seem to come in parallel to the actual line of the shore. So even if out in the ocean the waves are doing something different, it seems like when the waves get to you, they're always parallel to this line of the shore here. So, for example, like what if someone were out at this beach right here? And they would say, right here is where the water comes up, and here's the waves. But out here, this is not parallel to that. These two are not parallel to each other. I couldn't help but draw that. Sorry. So anyway, why is it that these waves seem to come in parallel to the shore? Something must be happening to change the directions of these waves as they go from this deep water into this shallow water. So I'm 1 minute in. I want to use 3 images to hopefully help you understand this. So in a previous video I talked about this trick, and I'm only going to do it really briefly here, but what we're doing is we're imagining that we've got these 2 wheels connected together by an axle, and they can go fast out here in the air. We're imagining this is a prism made of glass or something, plastic, who knows what. And when this bottom wheel hits the glass first, it gets slowed down, but this top wheel is still going fast because it's out here in the air. So it turns, it gets to go ahead a little bit while this wheel is kind of stuck. So that causes the ray or the wave to turn down a little bit. And so now we've got our 2 wheels, our imaginary wheel and axle here inside the prism. And which wheel gets out first? Well, it's again here, since the shape of this prism is this triangle, this top wheel gets to get out first, and it gets to go fast again, and this wheel is stuck inside the prism for a while, so that means it gets to turn downward again. So maybe you've seen, I don't know, other images of this happening, but this is called refraction. So I drew these 2 pictures, and we're going to try to understand what happens as waves come in from the deep water into the shallow water. So I guess what I want to do then is, in each picture, I'm going to say that some wave, or a couple of waves, are coming in like this. They're coming in this direction. So I'm going to put that in both pictures, or both images here. We have our waves coming in. And what do we know happens? We know that when these waves travel along toward the shore, we know that they end up going more like this, because they hit the shore parallel. What they don't do is they don't come into shore and end up going like this. They don't end up going in this direction. They go in this direction. So what's going to cause that? What must be happening is their speed must be changing. So as they go from deep water to shallow water, something happens to their speed. So if we use our wheel and axle trick again, so if we kind of forget that these waves are drawn here and draw our little wheel and axle instead, then we have this, and so this wheel and axle is coming in, and which wheel is going to hit this shallow water first? Here the water is shallow. This wheel is going to hit first. And what would cause it to make this kind of a turn from this way up toward this way? The only way it would turn that way is if this wheel were to go from slow to fast. And that is not what happens. So let's go up to this other drawing and do the same thing again. We've got our wheel and axle coming in. Drawing's getting progressively worse here, but it's not terrible. So which wheel is going to hit this shallow water first? It's going to be this bottom wheel. And what would cause this top wheel to swing around to make these lines come in parallel? The only way that could happen is if the shallow water slowed down this wheel. So there we have it. This must be what's going on, because this is not what we see happening in the ocean waves. So what must be happening is, in the deep ocean, the waves must be going fast, and when they come in toward the beach where the water is shallower, they must slow down. And that should kind of make some sense to you. I'm going to try and finish this before 6 minutes, but like, let's say here's our ocean and here's our beach, and it goes off like this. As the waves are coming in, what's in their neighborhood is just more water. But as these waves come into shore, they start interacting with the sand or whatever the bottom is here, and there's going to be some friction. And that friction is what causes their speed to change. And when waves' speed changes, when they go into something different, that is the turning that happens is called refraction. So refraction is what is causing this situation to happen.